Solve problem on turning moment diagram of rimmed flywheel. Given question: the T theta diagram of a diesel engine consists of intercepted areas which are plus 40, minus 85, plus 79, minus 68, plus 96 and minus 62 mm square in one cycle taken in the given order. The torque axis scale is 1 mm is equal to 75 Newton meter and crank angle scale is 1 mm is equal to 5 degree. Mean speed of engine is 500 rpm. Design the rim of the flywheel for the following data. First, limiting rim speed at mean radius 30 meter per second. Second, fluctuation of speed 2% around mean speed. Third, width to thickness ratio for rectangular rim section is 1.5, which contributes 100% Mi of flywheel. Fourth, material density is 7,200 kg per meter cube. Neglect the flywheel effect of hub and arms.
Let us understand how to draw the turning moment diagram for diesel engine from given data. For diesel engine, driving torque variable and load torque is constant. Now if we observe the given data, intercepted area in millimeter square is mentioned in plus sign as well as minus sign. So we will first understand this concept. As flywheel is mounted in between electric motor and load machine. So whenever the energy gained from the electric motor, the flywheel speed increases. And we have to show the area for the turning moment diagram in the plus sign, that is plus 40 millimeter square. Now when the energy is released to the load machine, then flywheel speed decreases. And we have to show the area that is in the minus form, that is minus 85. So this is the intercepted areas given, and this area indicates how much energy is gaining the flywheel from this electric motor as well as how much energy is released to the load machine. So first we have to show all these areas in the turning moment diagram. So how to draw the turning moment diagram? On vertical line we have to show torque in Newton meter, and on horizontal line we have to show theta in radians. Now for 1 millimeter square scale is mentioned. 1 millimeter is equal to 75 Newton meter and 1 millimeter is equal to 5 degree. So this is the crank angle. So we have to convert it into radians, that is 5 into pi by 180 radians. So how to calculate 1 millimeter square, that is 75 multiplied by 5 into pi by 180, which is equal to 6.545 joule. Now we will show all these areas. So how to show this plus 40? So plus 40 millimeter we have to show because the flywheel is gaining the energy from this electric motor. So we have to show above this load torque. As this load torque is constant, that means for all the angle, crank angle theta, there is one constant horizontal line. So flywheel is gaining the energy, so we have to show this area above this load torque. So I will show here for plus 40. So I will mention here. Now next is minus 85. That means energy in the flywheel is released to the load machine, and that's why there is negative sign. So flywheel energy decreases, that means speed is decreased. So we have to show minus 85 here. Then plus 79. So here we have to show plus 79. Then minus 68. So we have to show minus 68. Then plus 96. So we have to show here larger area plus 96. And then minus 62. So for minus 62 we have to show this area. So this is the driving torque. So we have to show this because this driving torque is variable. So we have to mention this. Now we will calculate maximum fluctuation of energy, and for that we will make here some construction lines. At crank angle theta is equal to 0, that is at this point we will consider point A. Then here after this cycle for plus 40 is getting completed, we will consider this point will be point B. And after this minus 85 cycle is completed, we will consider here point C. Then next point will be point D. Then here is point E, point F, and last one is point G. So these are the points. Now at these points we will calculate what is the amount of the energy. Now at the point A we will assume that the energy in flywheel is equal to A. So energy stored in flywheel at point A, that is at crank angle theta is equal to 0, which is equal to E. Now the next point, that is B. So what is the energy stored in flywheel at this point B? So here plus 40 area is equal to plus 40 millimeter square. So we will say that E plus 40. Then at point C, here minus 85, that is the energy is released to the load machine, and that's why here energy is decreased. So at point C, what is the total energy? E plus 40 minus 85. So when we make calculation, then we will get E minus 45. Then at point D, we will get the energy E plus 40 minus 85 plus 79. So when we make calculation, we will get E plus 34. Then at point E, so at point E it is E plus 40 minus 85 plus 79 minus 68. When we calculate this, then we will get E minus 34. Then at point F, so at point F it is E plus 40 minus 85 plus 79 minus 68 plus 96. So when we calculate this, we will get E plus 62. And at point G, it is E plus 40 minus 85 plus 79 minus 68 plus 96 minus 62. And it is equal to E. That is the original energy, that is at point A. Now to calculate maximum fluctuation of energy, we have to find out what is the maximum energy and at which point minimum energy in the flywheel. Now we have to observe this. So here E plus 40 plus 34 and E plus 62. So E plus 62 is the maximum number. So E max is equal to E plus 62. And we have to take the difference in between maximum energy and minimum energy. So where at which point minimum energy is there. So here E is there, E minus 45, E minus 34 and E. So E minus 45, this is the minimum or lowest energy. So minus in the second bracket E minus 45. Now when we solve this, so this plus E and minus E is getting cancelled. So when I remove this bracket, then this term will become E plus 62. Then minus E, and here minus minus it will become plus. So when I remove bracket, then this plus E minus E is getting cancelled, and then 62 plus 45, that is 107. Now for this 107 is the area, because all these areas are there. So 107 millimeter square. So for the 1 millimeter square, we have calculated energy 6.545 joule. Now we have to multiply with this energy. So 107 multiplied by 6.545 joule, which is equal to 700.315 joule. So this is the maximum fluctuation of energy in the flywheel. Now we will calculate moment of inertia of the flywheel. So from the maximum fluctuation of energy, delta E max, formula is I omega square Cs, where I is the moment of inertia, omega is the angular velocity, and Cs coefficient of fluctuation of the speed, and it is mentioned. Now omega, how to calculate? So n, that is the speed is mentioned, that is 500 rpm. So omega is equal to 2 pi n by 60, that is 2 pi 500 by 60, and which is equal to 52.36. Now we will put the value. So delta E max we have calculated, I is unknown, omega is calculated 52.36 square, and CS is mentioned in question 0.02. So moment of inertia I is equal to 12.7722 kilogram meter square. Now this is the moment of inertia of the flywheel, but here rim flywheel is mentioned in the question and we have to find out the moment of inertia of the rim. So how to find out? So if we observe the question, in question rim contribute 100% moment of inertia to the flywheel and it is mentioned. So we have to use the value of C, that is that factor C is equal to 1. Now suppose in question it is mentioned that rim contribute 90% Mi to the flywheel, then we have to take C is equal to 0.9. So we have to take IR, that is the moment of inertia of the rim, is equal to C multiplied by I, and this factor C we have to take as a 1 for 100%, and I is 12.7722. So IR which is also equal to 12.7722. Now limiting speed V is given and we know that the speed V is equal to R into omega. So here radius Rm into omega. Now we have to find out the radius for the rimmed flywheel. So we will mention here at the base small m. So Vr is equal to Rm into omega, where V to the base r. So why to the base r? Because this is the linear velocity of rim is mentioned. So it is mentioned 30 meter per second. So 30 is equal to Rm into omega. Omega is equal to 52.36. So Rm is equal to 0.5729 meter. So we will convert it into millimeter, 0.572.9 millimeter. Now this is, we get the radius for this rimmed flywheel. Now again we have to find out the thickness. So here thickness and width, that is T and B, is not mentioned in the question, but the relation in between this T and B is given. That is this B is equal to 1.5 T. That is width is equal to 1.5 times of the thickness. So here again we will mention here the second relation, that is moment of inertia of the rimmed flywheel is equal to mass multiplied by radius square. So this mass of the rimmed flywheel multiplied by radius of the rimmed flywheel square. Now how we can define this mass? So we know that mass of flywheel, that is 2 pi r. Because of the rim we will consider here the perimeter. Now in previous case when the solid flywheel was there, then we have mentioned the area of the flywheel, but here only rim, that is the outer perimeter, we have to consider for the rim. So 2 pi Rm into T into B into rho, that is T is the thickness, B is the width and rho is the density, and Rm square as it is. So this Rm and this Rm will become Rm cube. So we will put the value. So IR is equal to 12.7722, which is equal to 2 pi. Now Rm 0.57. So we have to use the standard unit for calculation. So we have to use the value in meter. So we have to use this 0.57 meter, that we have to use. So 0.57 cube into T into B is equal to 1.5 T into rho, that is density, 7200. Now when we solve this, then only one unknown factor, that is T. So T is equal to 31.88 millimeters, that is equal to 32 millimeters. Now how to calculate B? So B is equal to 1.5 into 32, that is equal to 48 millimeters.